Hello everyone, my name is Lisa and I'm glad to see you all at Winter Data Meetup organized by DataZen Community and Community Day. Meet Fahim Khan, an expert in AI and data strategy, here to show you how AI agents can transform work. Learn the difference between traditional automation and AI-driven strategies and see real-world examples of how businesses use AI to boost productivity. Don't miss this chance to discover practical ways to integrate AI into your workflows and stay ahead in the GenAI era. Before we jump into our session, I would like to take a moment to ask for your support in growing our community and recognizing our incredible speakers. If you're enjoying today's discussions and want to stay updated on upcoming events and talks, please take a second to hit the like and subscribe buttons below. Your participation not only acknowledges our efforts but also helps us reach a wider audience, allowing more people to learn from these insightful discussions. Also, in the video description, you will find a link to the talk page where you can share your feedback, award the speaker a badge, and rate the session. Your input is incredibly valuable. It helps us improve future events and ensures our speakers get the recognition they deserve for their hard work. Additionally, we would love to hear from you throughout the talk. If you have any questions or insights, feel free to drop them into the chat. Our team will be actively monitoring and we will gather your questions for the Q&A session at the end. Your contributions make the discussions even richer, so don't hesitate to participate. And now, let's welcome our speaker to share his valuable insights with us. Fahim, the stage is yours.
Thank you very much for the introduction. Again, my name is Fahim Khan, and I will be talking about how to use, I would be introducing agents and in it. So I come with about 30 plus years of experience in management consulting, usually around big data and analytics. And for the last 3 years, I've been very much engaged with OpenAI and other LLMs and building solutions based on those. So let's dive straight into the topic. What I'll talk about today is what are these AI agents and agentic AI? There's a big buzz around it in the industry today. And also, what is the difference between this and traditional RPAs and how to work together with them, and then give some use cases as we mentioned earlier. So if you remember 2.5 years ago, when first introduced OpenAI and GenAI became more streamlined, everybody jumped into using GenAI for anything and everything. And quickly people realized that although they were great tool, and they're still very great tool, there was some very inherent limitations, and then there were some security and hallucination and some of those issues in it. So as part of natural evolution, late last year, there was a big drive to move towards what is called AI agents and agentic workflows. And 2025, as my topic over for this talk is going to be year of agentic AIs and agentic workflows. So what's the difference? So if you look at traditional um, LLMs and chatbots and copilots, they work in a very streamlined, one directional way. And it's a very sequential process that works from point A to point X, but in going in straight path. There is very soon, very quickly, people realized that there has to be ways to verify information as it comes in. There has to be ways to divide and conquer and be able to do work in small chunks to make it more. For example, if you have uh, a question asked from a copilot, it brings information. What do you do to verify that that information is correct? So you need to be able to go back and correct. And sometimes you may need more than one source to validate that the information you retrieve from one place is good and can be used. In order to solve that issue and to reduce hallucination and some of those things which come inherent with the previous process, is the introduction of agents. So what are agents? So AI agents, if you think about it, are individual subset task working agents which look at every request and a portion of a request, of a big request, and perform certain functions in it. And they have a very specific task that they do, and they can do that repeatedly on it. Whereas if you take a whole bunch of agents which put together will perform a complete set of tasks that is being asked by the user, is where agentic AI comes in. So agentic AI essentially breaks that task into multiple agents, and each agent does a specific task. And you need some place where all those tasks are combined together. There's a reasoning together going on, and then taking based on the information that is received from one agent and deciding what actions to take. And in the process, if the agent has discovered something new, then update your process so that next time a similar question comes in, it works better. This is where agentic AI as a whole takes small agents and makes it into an overall problem solving solution. So that's why agentic AI's agents work together, and agentic AIs have become most popular to do that. So how do they work? Although there are several ways that these agentic AI systems or multi-agent systems work, on the right-hand side, as you can see, there are 6 very common ways of doing it, but I'm going to highlight some of the very common ones just to in the interest of time. So one of them is the network-based agents. So this is a setup where each agent, so each of these green boxes represent an agent. And in a networks environment, these agents, they communicate with each other. For example, if one agent retrieves information, it passes it to the other agent to do something to it. The other agent processes something and it may send it to a third agent or return the information back to the first agent. So these, in this scenario, all agents interact with each other based on what is needed. Then there is a different process, which is a supervisor agent. In this, one agent acts as the supervisor and assigns tasks to different agents and receives information back. And it can go back and forth with it. And it could be sequential or it could be in parallel that these agents work. Then there's a third major one, which is called supervisor, which is calling tools. In this case, the LLM sends information along with certain pieces of information, just like you would do in the traditional APIs. And so it sends some arguments to a specific tool to perform a function and then receives information back. And these tools, just like traditional API calls, they have these arguments. Based on those arguments, those tools react, get a result, and feedback to the agent. In a much more complex scenario, which is a very is similar to the chain of thoughts kind of a thing, where one agent will send information to another agent, which in turn has sub-agents under it, just like the supervisor model. And they perform a whole bunch of tasks. Those agents, when they're solved, they go to their supervisor agent, and that supervisor agent again goes to the top level agent in the hierarchical system. And last but not the least is a much more complex where multi-agent workflow are there, where some agents work in a very deterministic flow, whereas the other work as back and forth. So each agent have certain rights with which they can communicate with each other. So this way, what happens is one agent can assign tasks to very specialized agents to do something, whereas other agents can also subdivide tasks and give it to multiple agents to do different things before they pass that information to a third thing. So kind of a complex area. The idea on these is that there is no one solution of agentic workflow, but it gives you a good variety of different processes or different processes with which you can have a supervisory agent or that assigns tasks to agents and get your results back. So let's take a couple of examples to see how this works and what are a couple of the frameworks in which it works. The most common one that you will see in different places is called React. And React over here means reasoning and acting in language models. So this one is one of the most popular one that is currently being used. What happens over here is the first agent uh, takes the information that is provided to it and it thinks about it. And autonomously, it makes a decision on what are the steps I need to perform to get the required results back to it. So this is in return, what happens is it will create a ledger of activities and things that need to take place. And then it passes those set of activities into subtasks that are performed in it. So for example, in this example, which I'm showing over here, this kid wants to get some homework with the history assignment. When it asks the supervisor agent or when it requests that I need help with my history assignment, the supervisor agent makes a determination in order to work on a history assignment, I need to do certain tasks. I need to look at what is the topic that this student needs to take care of or write an assignment on. And let's say the type assignment was last 50 years of European history. Then it has to now assign subtasks to it and say, last 50 years means my current year minus 50 years. So that will be year so and so. So it is one task. The other task will be based on those time frames. It will say year one to year X, what were the key events that took place in Europe? And then it would say reconcile those and identify key events versus general events. So filter out the noise and come back with this, and so on and so forth. So that's what the task initial plan task list is. Once that ledger or plan task list is created, it is passed on to this act area where each one of those tasks are assigned to individual agents, and each one of those agents performs a task. Once all that information is returned back to the task list, it is sent back to evaluate. Now, this is the one of the important steps in this agentic workflow is look at the results back and evaluate, did I get everything that was needed? So for example, if the return comes back and it has only 3 events in it, this would determine that this is a 50 years of history. Is it realistic to have only 3 events over there? Maybe I need to look into more resources. Maybe I need to look into different search criteria to get more information. And then based on that, it goes back and updates the task list and send the task again and say, instead of looking at only Wikipedia to get that information, I need that information from history textbooks. I need to go and look at Encyclopedia Britannica and so on and so forth. This way, this loop kind of determines whether I am in a good situation or I need to go further. Very important in this. Similarly, the another agentic workflow is called agentic RAG. Now, traditional RAG, we have a standard workflow with which we identify where to retrieve that information from the vector database. It retrieves that information and it brings back. Whereas in agentic RAG, slightly different approach takes place. So once the question is put to the LLM, it decides what are different sources that can provide me that information. First is, okay, I will look into my vector database. Maybe I need to also go and query the web itself. Maybe I need to also look at a content repository, which may be in the form of PDF files and text, and maybe I need to write a short piece of code to do a certain amount of calculation or search on it, gets that information back. And just like the previous React, once that information is collated, it kind of compares all of that information for consistency and accuracy, and then evaluates the response. Once it evaluates the response and says, is my answer quality good? I have 3 pieces of information on a certain topic. Are they all consistent? If it is not consistent, why was it inconsistent? And it sends it back and reformulates the search and says, instead of looking at these websites only or this document source, maybe I need to expand my search to a larger repository. Maybe I need to look into another sources like user forums and all that. And this cycle goes on very rapidly. And once there is good consistency and all that, it responds back with the answer and output is retrieved. What it does in return is also it will go back and update the search criteria that next time a similar request comes in, I will perform these additional tasks to do that. The third most common area of agents framework is the code act, very similar to React. In this case, the framework actually goes in and writes Python code to perform certain functions. And these Python codes, snippets, they can self-debug, they can do it, and they go and execute and come back with the result. For example, if a question comes in, a very complex algebraic equation to solve this equation or something like that, it looks at the equation and it says, in order for me to solve this equation, I need to chunk it into multiple steps because it's not a one-step solution. And each one of those steps, it will be translated into some kind of a Python code, which executes, gets those results. Those results are combined together, and the result is brought back. So that's the code act, very similar to React, but in this case, the RAG element or the agent will write Python code. Just as an illustration, I'm not going to walk through it. By no means I'm endorsing one versus the other. I found this from Magentic 1, which is the framework from Microsoft, a very good depiction of how this works. Just like I said earlier, task comes in, the orchestrator creates a task ledger based on the task and previous experience, assigns that to the progress ledger, where each agent task, when it is completed, it evaluates and marks that all the steps in that ledger are completed. And once they're all completed and there is no delay in it, no stop in it or stall in it, it comes back and responds back. While it is processing, it goes and writes code, for example, to do certain stuff. That code is then injected into a computer terminal, which executes the code. And based on the results which are brought in, combined with the results from the web search and also from the file search, combines all the results, looks for consistency, and if it is good, it goes back. If it is not good, it updates the progress ledger and it comes back and does it again. I put the link over here. People who want to go and look into details, very easy to find that detail. Now, the obvious question which comes in immediately is, does this mean that what I did as RPA, robotic process automation in the past, is the same as agents? Yes and no, but they're not identical. Traditionally, RPAs are very prescriptive, automated, repeated, rules-based tasks which an individual performs or some kind of automation performs. And they're very rigid. You repeatedly do the same thing every time, and it goes through a certain amount of workflow and it is done. It uses complete human oversight all the way to the process. It can integrate with some systems, but it cannot work in isolation by itself and is not self-learning from the way it is. Whereas agentic AI, it can handle a lot of complex decision making based on dynamic interactions, and it self learns. And it can also bring input from different kind of data, structured, unstructured data, and based on the question context, it can adapt to it, just like I was showing in the previous example, that it can write code if it has to extract information from a certain source. It can also go to web to surf and get the information, and also through the documents to do the information, and then aggregate, reason, and compile the result and bring it back. And it can also react and act with multiple systems, interact with it. So there is that subtle differences. So the obvious question comes in, okay, if that's the case, then can we use them together? The answer is yes. So you can use them in more than one way, whether you do a rip and replace or do some complementary tasks. So I listed some of the common things that you can actually enhance your workflow, whereas some of the traditional basic tasks are performed by RPA, and agentic AI picks up those different pieces or tidbits of results and use that into decision making and automate the decision making based on that. And similarly, if there is error handling, whereas RPA traditionally will say, here is the log analysis, and this is the error which was uh, extracted from that log. Agentic AI can look at traditional solutions to that and perform some remediation or mitigation autonomously. And similarly, if there is precision-based systems, then you can take it to the real-time changes with agentic AI, because it's not only going to your traditional information which is available to RPA sources. It can go and look at multiple solutions and dynamically update their results. So this is some of the tasks which they can complement. Typical use case example is in a customer service. If there is a question, RPA can do the initial work, or traditional RPA processes can extract traditional information and build sources to draw upon, where agentic AI can actually take some of those responses and perform other functions on top of it, like sentiment analysis, like summarization, and so on and so forth. Similar things, I'll show an example later on, that supply chain management. If traditional RPA can do inventory check, agentic AI can actually perform a whole bunch of additional validations and others, and go through the procurement cycle automatically by providing the right information to the right systems and validate information based on that. And last but not the least is, just like we mentioned earlier, if you're in IT operations, RPA looks at the logs, incident logs, and tabulates it, where agentic AI can look for similarities, correlates results, look at solutions maybe in user forums, web-based solutions, product manuals, aggregate that, and predict or recommend a solution based on those. So bottom line is, they can complement each other and become more productive that way. So let's take a real life use case in invoice processing, just like I was using that example before. I'm not going to read the whole process, but typically what happens is there's some kind of an automation tool where email comes in with to the accounts payable. Somebody opens up that email, the person who's providing this BPO services verifies the information in that attachment or the invoice. Based on that, if everything is good, process it. If not good, sends it back, and so on and so forth. And once it is all good, then that information is entered into a payment system, where payment system goes in and verifies that against the different verification processes, whatever they have. And then it goes to the payment processing system, and so on and so forth, until the payment is completed. In all this process, there is a whole bunch of human interaction where different kind of checks are done manually, and also there is those very rigid standard processes to make it more better. What agentic AI does is actually automates and constantly update that process. So when an invoice comes in as an email attachment, the the attachment is taken out of it, and by the inherent capabilities of LLMs, it goes in and verifies for the accuracy across how it is supposed to be, and accounts for any variability in those invoices which are acceptable and not. And if there are discrepancies, it can write an email back automatically, send it back to the sender or a vendor or a business owner. But if everything is good, feeds that information to the payment system, where payment system has another agent, let's call it the payment agent, looks at the whole context, looks at the historical data, looks at the other business rules on it, and if everything is good, moves it forward automatically to the business for the approval process. And the execution agent, or the payment execution agent, then takes that information, processes it through different rules and different things, and then it executes the payment workflow. Essentially, agent performs all those comparisons, validations based on historical data, making sure that whatever is being processed, even with the variations, is acceptable. Is it part of the contract? And what are the rules engines that are required on it? And if everything is good, pretty much automatically do it. Now, having said that, you can always include human in the loop, where you can either pause the system at a point or send it for further verification and reinitiate the process. It drastically shortens the whole process in doing this way. Similar use case in healthcare. For example, if there is a pre-authorization required, same thing happens over here, slightly different process. Traditionally, when a request comes in from a doctor or a clinic, somebody goes in and does initial review, then they open up the contract rules or the insurance rules around that service. Then they do an evaluation, then it sends it to for somebody who does the clinical evaluation to say medically if that particular service or that medication is advisable or not, is it covered under the insurance policy, and if it is policy, then they make either approve or deny the request and processes it. Agentic AI process can pretty much automate all of those, because as soon as that information comes in, it can validate if everything is there based on the rules or the agent's performance, and agents look at it. So the AI agent over there quickly looks at all the information which is in there. If everything is there, great. If not, it sends back for more information. And if everything is there, then it quickly compares it to what are the insurance policy and contract rules for that particular individual. And based on that, it determines whether clinically, traditionally, for a similar kind of use cases or a similar kind of illness, is performed or not. All this is done based on information that has been built over time and verified against this without human interaction. And then it communicates back to the user. So this way you can drastically reduce your time cycle in it. So in conclusion, most of the traditional RPA processes can be automated using agentic AI and enhanced on automatic decision making and improved as we go on. So I'm going to wrap up my talk with a couple of very key points or takeaways from this. Is yesterday it was co-pilots, which was step one. Now those co-pilots are becoming autopilots to become much more autonomous. Just like I said, the supervisor agent can make decisions and learn and make enhanced decisions in future, pretty much work autonomously without having to interact with it. So autopilots is the way to go. And since the introduction of autopilots, there's a new term that will be very mainstream going forward, which is service as a software. So essentially, you are taking traditional services and making it as a software package, and it transform a lot of those manual labors and services as part of a solution of your software. The advantage of this is that you can assign specific tasks to your workflow and services, and the software performs all that based on what you're doing, and that actually take the solutions much more personalized and constantly learning and constantly enhancing. With that, I'm going to wrap up my presentation, and we'll open up to questions.
Thank you, Fahim, for this presentation. Yeah, we have a couple of questions for you. So the first question is, what AI systems or solutions require agents and multi-agents?
So you can apply multi-agents to almost everything which can be divided into subtasks and use it. The two examples, like I gave, one in finance, one in this, supply chain is another very common example where AI agents are very helpful, because supply chain, uh, for example, you have to receive a demand. Once you receive a demand signal, you have to look and check in inventory. If you look in inventory, if the thing is available. If not available, what are the business rules? Can you offer something else? So you could apply that to supply chain, for example. Just like I said, in financial industry, for example, financial crimes can use multi-agents. And when a bank or financial institution wants to verify somebody's profile and want to understand if there is compliance with all the regulations and there is no financial crime being done, one agent can go in and first validate what are the new regulations. Based on that regulation, the second agent verifies that individual or that corporation's identity and try to matches with those regulations and verifies if there is nothing different. If it is the same, great. Or if it is, let's say, inconsistency in name, inconsistency in something, or inconsistency in any of their dealings which are questionable, then the third agent verifies how much is it in compliance, or is it questionable. If it is questionable, then it triggers a warning to it. So the general answer is anything that requires more than just a linear process. Agentic workflows and agentic AIs are the best way to use it.
Thank you. Got it. The next question is, would you recommend to implement whole solution at once or just one agent by one?
Very good question. So that's a question which is normally asked. If you have been traditionally using LLMs, think of it that LLM was probably your one agent in the past. Just example, for example, were the homework assignment for that kid, very simplistic example. In the past, if I had asked a question, go get me some information on 50 years of European history, I would get one answer back and I'm good with it. So that's your one agent. Now, if you have matured from there, or you understand the limitations of that answer and you want to say, I want to be able to verify that answer with more than one source, or validate that I have the 50 years really captured and all the key events captured, and that can come from multiple sources, then you should be looking at multi-agent. My recommendation is, if you think that your process needs more attention than just a one single linear process, look into multi-agent agentic workflows. And just like I showed in an earlier slide, it could be a simple multi-agent solution or a complex multi-agent solution based on what you're doing.
Okay, thank you. Is there a super agent that replaces all kinds of agents, like the universal one?
There is so there is no super agent, there is a supervisory agent. So supervisory agent then subdivides the tasks to small agents. That's
Mm,
the whole idea of it. So instead of having a super agent, you want to chunk the task to multiple agents. The biggest advantage by chunking the task, even if you think one agent can do all those sequentially, you can get your results much faster, number one. And number two, in between, you can do reasoning between results from one agent to the other agent and modify your task. And the supervisor agent autonomously can still direct which agent to engage at what time.
interesting. Thank you. What is relationship between Magentic One and AutoGen?
Magentic 1 is built on top of Autogen. So the original Magentic 1 was built using Autogen framework. It's the next stage of evolution. My understanding is since then, Magentic 1 has expanded beyond what was originally part of Autogen framework. So yes, they are related from the perspective is the next set of evolution from Autogen to Magentic 1.
Okay, got it. Do you think that AI can replace software developers? Is it a question of a proper agents framework?
I personally believe there is still room for human feedback, like I had mentioned throughout my this, but the chances of having less errors is increasingly becoming more visible as part of this agentic workflow. Like I mentioned earlier, like currently most of these agentic workflows, they can write their own code, but only in Python they can actually debug their own code in it. But if you need a much more complex reasoning and much more there, um, personally, I don't believe it is there. There is still some human interaction required, but it has come a long way and it can drastically reduce your work. I would recommend having human in the loop wherever possible.
Whew, okay. Could you explain AI agents and examples of self-driving cars?
Oh, yes. So self-driving cars was one of the early uses of AI agents. If you imagine, I'll take an example of Tesla. Everybody knows Tesla. There are different components in Tesla which are looking at different pieces of information that it receives. For example, there are cameras which are looking at lights from the car in front of it. There's a camera which is looking for humans which are around this. There's cameras. Each one of these agent is evaluating individual components. The agent or the multimodal agent, which is looking at the markings on the road, is also just determining whether you are in your lane, while as the agent which is facing forward and looking at road signs is looking at the stop sign. The agent which is looking at the light. All these agents come together to come up and determine that I have a stop sign, which means I have to stop. Or if there is a bright red light in front of me, that means a car has stopped in front of me. I have to stop also. So there are different agents they work. So in autonomous driving cars, each one of those individual components which are brought into a decision to do certain action is performed by agents, and they're all into an agentic workflow, come together to make a decision.
Great, thank you. It was interesting. And the last question for you, the funny one, I guess. Could I use AI to create AI agents for other AIs?
That's an interesting question. I did read a couple of articles where determining what agents to use rather than writing agents. I see no reason to provide the right context to your code development and read that developed code for that agent, I see no reasons not to do that. I believe there are certain frameworks available to do that. Something I'll be more than happy to look into and post it.
Great. Thank you. So it was the last question. Thanks for joining today's discussion. In the description, you will find a link to access the presentation file and recordings. Don't forget to say speaker thank you by awarding a badge and rating the talk. Be sure to subscribe to our channels for more content like this, and we hope to see you at the next session of the Winter Data Meetup. Bye bye.
Thank you. Thank you for your patience.